So in this video we will talk about Arista's EVPN with L3VXLANs, and I'll go through the setup. What we have here is essentially two switches, switch 1 and switch 2, and they're just directly connected, but this could be a bunch of routers in the middle, it could be a WAN cloud or a core, could be anything, but for simplicity, it's just a point-to-point IP link with a subnet 13.0.0.0. This one is .1, and this one is .3 for the sake of reference in the configs that I have here that we'll go through. So with EVPN, which is BGP control plane, what we will achieve here is an L2 extension. So we have this subnet, this vEOS 1 router, which is on 10.1.1 subnet, and the vEOS 2 router, which is also on 10.1.1 subnet, and they're going to be connected on VLAN 10 with these two VTAPs on these switches. To make that happen, to extend VLAN 10 across an IP cloud or IP connectivity, you need to be configuring two VTAPs so that the MAC information, MAC routing can happen, MAC addresses can be exchanged between the two VTAPs, and we also have an external vEOS 3 v3 connected on VLAN 20 on this switch here. So these two vEOSs are on VLAN 10, and if they want to reach the outside world, they're going through vEOS 3. Consider this to be a gateway or whatever. But this will demonstrate how an L3VXLAN, L3 being, we will configure a VRF so that the routing to a different gateway, an outside gateway, can be achieved. And if you need to add more VLANs, you can add VLANs to the VTAPs and get the MAC exchange. So we'll look at the configuration that is required for MAC routing and the configuration that's required for external routing. All right, and that's why if you don't need external routing, if you just need to extend VLANs, you don't need L3VXLAN. All you need is L2VXLAN, and that would eliminate the requirement for VRF. All right, so let's go and clean this up, and I will go through. So now we have the setup, which is pretty straightforward, right? The first computer here is on VLAN 10, wants to talk to another computer here on VLAN 10, sitting on same subnets, MAC routing happening over an IP connectivity. All right, now let's look at, and if you look at the Arista documentation or any other web documentation, they just would dump everything mixed together. I have simplified this concept or these configuration, and put them side by side for my own sake, and if anybody can benefit with it, to see how the configuration is going to look like. Let's zoom into the configuration again. I will bring in the routers. I will bring in the vEOS routers, vEOS 1, vEOS 2, and vEOS 3. I'll bring in the switches later. Let's just look at the configuration first. So I'm going to take a look at, bring it up here. I'll try to squeeze this as much as I could. But this is how your switch 1 configuration is going to look like. And you will define a VRF, and you can name it whatever whatever you want. Again, VRF is only required for L3VXLANs. So this is required for L3VXLANs. This is the VLAN 10 connected to the vEOS 1 down here on the left side. This interface is not connected with anything. It's left alone. Ethernet 3 is the network between the two switches. I have configured Ospf. You would need Ospf or any kind of routing, static routing, which is painful, but enabling Ospf would let you exchange the loopback 0 and the loopback 1, which is required for BGP EVPN. So I am advertising loopback 0 and loopback 1 into Ospf, and therefore I've enabled Ospf here in the middle of the two switches. Then on the VLAN 10, where the two computers are connected, to vEOS 1 and vEOS 2 are connected on the same VLAN, you would put that VLAN in the VRF and define that subnet. And here's the VTEP interface VXLAN. You would use the source address as loopback 1. That's why you need the connectivity. Let me see if I can maximize this more. It's very difficult to squeeze everything in one screen and demonstrate. So we took care of this part. We're into the VXLAN part. You have interface VXLAN. This is where your VTEP is. This is basically encapsulating L2 into L3. This is standard configuration. This is where you would map a VLAN 10 into a L3 VXLAN with the VNI, and this could be a number that you choose. And then you're putting the VRF as well into this VXLAN because it's an L3 VXLAN. If it's not an L3, if you're just concerned about east-west traffic, you would not do this. But here in this demonstration, we're talking about east-west and north-south traffic. So remember, the north-south is going outside the, oops, this is going to erase the, so I have to be careful. All right. Then you're going to enable, by default, the switch routing is not enabled in the switch. So you're going to enable IP routing globally for Ospf, and you're going to enable the VRF routing as well. Here's the BGP configuration. Let's see if I can go down. And the configuration is pretty straightforward if you can map it and then simplify it. If you go through the documentation in Arista and other websites, it's people have just dumped everything. It's very difficult to figure out how the simple configuration is going to work. The router BGP, you're neighboring with the other switch, which is this guy on the physical interfaces, and you have to send the community. This is a must. This pops up by itself. Then if you're just doing east-west, then this is all you need, right? And then this part as well. But if you are doing north-south, going to the outside world, from your fabric, you're going to need this part. So VLAN with route text, you come up with these numbers. It has to match on both sides. This is typically the loopback and the VLAN number I've chosen here. You can choose whatever, but it has to match on both sides of the switch. Address family EVPN, you just point to the physical interface of the switch and you activate address family IPv4. This is where you're exchanging your loopbacks. I've done this in BGP, but it's not necessary. I think it's a leftover configuration, so you can probably eliminate this part. Ospf is doing this. This is just required. In fact, I don't think this part is required at all. So you can try without configuring this part. I'm going to have to clean up later and see if this works. And now for the north-south connectivity, you will define the VRF1 with the route descriptor and a number of your choice, and do import and export on the VPN, and then redistribute connected, and then the Ospf is for your loopback exchange. So that, that's why I scratched this part out, because Ospf is taking care of the loopback advertisement. That is on a switch 1, because switch 1 only has VLAN 10. Let's go take a look at switch 3. Pretty much similar, with the exception of VLAN 20, because VLAN 20 here got pretty much everything similar to switch 1. VLAN 20 here is configured as a outside gateway, connectivity to the outside world. And see how this guy is not mapped. Only VLAN 10 is mapped, not 20, because I'm not exchanging MAC. I'm not doing any MAC routing for VLAN 20. If you need to, then you'll have to add it. But VLAN 20 is for north-south, and VLAN 10 is for east-west. If you want east-west MAC extension of VLANs, MAC routing, you need to add that VLAN here. But here I'm just demonstrating that VLAN 20 is used for north-south traffic. BGP is going to look pretty much the same, and as you can see here, I do not have VLAN 20 here because I'm not exchanging MAC. This is for the MAC routing, east-west. Again, I don't think you require this part. You can eliminate it. This is left over from my last testing. And you have VRF1 configured as exactly as on switch 1. And Ospf looks the same as well. With that, pretty straightforward configuration. You just have to understand what you need. VLAN 10, when do you need VLAN 10, VLAN configuration in BGP, and when do you need a VRF configuration in BGP. If you eliminate VRF, that is typically required for routing, symmetrical routing, and north-south routing. If you need that, you'll have to put VRF here in the BGP configuration. If you don't need it, all you need is VLAN 10 in the BGP for east-west routing. Now let's bring in the routers, and I'll probably try to clean this up and see if that works too. Switch 1, switch 3, vEOS 1, vEOS 2, and vEOS 3. So we got all the routers. Here's my show interface on vEOS 1. It's got a 10.1 network connected to the switch. Ignore everything else. And I'm going to ping vEOS 2, who's connected on 10.1.1.2, and this is connected via the switches. There you go. Right, this is simple. My IP route is default gateway to 10.1.1.10, which is the virtual address of VLAN 10 that we saw. If you did not, I'll show you. So here's my configuration on switch 1. As we saw, I cleaned it up. The VLAN 10 address is IP address virtual 10.1.1.10. It will be exactly the same on this side. IP address virtual 10.1.1.10. It's not IP address, but virtual. So virtual address, so that you can respond to as a default gateway, because this guy is configured as his default gateway is 10.1.1.10, and his default gateway is also 10.1.1.10, right? He's reaching this guy and he's reaching this guy for routing, and that's called anycast. Let's look at the show. Once you have your EVPN come up, you should be able to verify it by the show BGP EVPN. You will get all these routes. Summary will show you established here, right? Now, if you look at the global table, you don't see these routes. But if you look at the show IP route, VRF1, you'll see the BGP routes coming from this switch. Because in this switch, I have one extra thing, and that is the default route that I'm advertising right here. This default route in VRF1 is getting advertised with the next hop off, vEOS 3, which is this guy, 20113, and he's got some fake addresses, 100.111, 200.111, which is, let's just say it's an internet or external routes, and I should be able to reach it, and I can when I don't even have these routes in my global routes. See, they're only coming as a default. I can only do that because show IP route has a default static route that I'm redistributing into BGP. Show run a section router BGP. If you go to VRF, I'm saying redistribute static. So you have to pay attention to these little things to make this thing work. But essentially the idea here is that you have east-west between vEOS 1 and vEOS 2. You have the MAC routing enabled. And between vEOS 1, 2, and 3, you have north-south routing enabled. Here's your north-south, right? Here's your north-south going, and here's your east-west going. With this simple configuration, you have actually implemented your BGP EVPN with Arista. And it took me a little bit to go through the documentation and sort this out. But once you sort it out and put it together like this, it makes much more sense. And you would not, I haven't seen any document out there that puts it simply. Everything out there is much more complicatedly implemented. But essentially, this is how you would implement BGP EVPN with Arista switches. Again, Arista switch is a little annoying. The vEOS, you can look at the video that goes through the installation. It reboots several times if you want to do a clean setup. Once you do the clean setup, the first interface, let me show you the Arista Oracle VirtualBox settings. So here's your switch one. Look at these settings. Your first will always be the management interface, which I've configured with the local box, which basically means that this is your local box, VirtualBox interface. This guy right here. And he's on 192.168.56. So once you put the Arista's first interface on VirtualBox interface, you'll be able to SSH or Telnet into it. All the other interfaces you can use. This is E0 or E1, E2, and E3. So if you look at the Arista switches, you would see show interface status. You'll see E123, that's E1, E2, and E3 mapped right here. and adapter 1 is mapped to the management interface. And if you look at the show run interface management 1, I have configured it to be on the same subnet as the VirtualBox on your Windows. 192.168.56, 192.168.56.11, and 1, so you should be able to ping from your you go, and then telnet into it. The way I did telnet is obviously you look at the you go into it first through the console of VirtualBox, you no-shut the telnet, configure the IP on it like this. And then you no-shut the management. After that, you basically go to your PuTTY, say, give the IP address of the switch on port 23, which you are doing telnet, not SSH. SSH is you have to configure the service. This is the easiest, and then you pop it up, it will pop up. You also have to define a user, which, so you basically say username, and password, whatever. I'll show you the command for that too. Configure username A, use secret A, and then privilege 15. That's what you got to do so that you can log in. If you don't do this command, it won't let you come in. All right, let's quickly show run section BGP. I'm going to clean that IPv4 just to make sure. No address family IPv4. Okay. Can I still ping? Yes, I can. Can I still ping? Yes, I can. So yeah, that was from leftover. You don't need router BGP1. You don't need the address family. It's still not going away. So you're gonna have to go address family IPv4, no network, 1. Show run section router BGP1. There you go. Now it's gone. Cleaned up. Should still work. Bingo. So essentially I took off the IPv4, which was a leftover. You just need Ospf for your route loopback exchange. You just need Ospf to do loopback exchange. You run it on your transit, and then you advertise your loopbacks, and then you are all set. Hope this helps.